In this example, we're going to work with propanoic acid, which is a weak monoprotic acid. We have a concentration of 0.1 moles per liter solution of propanoic acid, and we calculated the pH, 2.96. We want to find our acid dissociation constant, Ka, and our percent ionization. Let's start with defining what percent ionization is. So we're going to find how much my acid is going to ionize when I put it into water. So my ionization is equal to how much hydrogen ions I will make divided by my initial concentration of my acid. HA represents any acid, times 100%. So in this question, we're able to calculate our ionization here of hydrogen ions because we're given the pH. So we take 10 to the negative 2.96, and we get 1.096 times 10 to the negative 3 moles per liter. So when we put propanoic acid in water to make a solution of propanoic acid at this concentration, we were able to ionize this much. So when we look at our equilibrium expression, where HA is propanoic acid, hydronium and hydrogen ions are representing the same thing. Hydronium is what will exist in nature more accurately. So initially, we have 0.10 moles of propanoic acid and nothing of our hydrogen ion and our conjugate base. Then there's a change, and the change is actually going to be how much we're able to ionize. So we're going to say the change is negative because I'm decreasing my concentration originally from 0.1 by how much I'm able to ionize. So my change is negative 1.096 times 10 to the negative 3. This is increasing by a factor of x for both. At equilibrium, I'm able to solve that 0.10 minus my change is equal to 0.098904. My change is my hydrogen ion concentration, so it's going to be the same since I have a 1-to-1 ratio here for everything in my equation of 1.096 times 10 to the negative 3 for both species here. Now that I have my ice table, I can solve for my Ka, and I can also solve for my percent ionization. So let's look at our percent ionization. It will be 1.096 times 10 to the negative 3. That's how much I was able to ionize into hydrogen ions, starting from 0.10 times 100%. My molarity will cancel out here, and I will be able to get 1.1%. This reaffirms that this is a weak acid because we know that if we have a strong acid like HCl, when we put HCl into water, 100% will become hydrogen ions. A weak acid like propanoic acid, we'll just say HA, this is going to shift more towards the reactants, and I was only able to ionize 1.1%, which is a small amount. All right, for our Ka, we know that we are going to take our hydronium, multiply by our conjugate acid, divided by HA. Water does not exist in this equation because it's a pure liquid. I will have 1.096 times 10 to the negative 3 squared, because it's the same for hydronium and my conjugate base. And then HA at equilibrium is 0.0 98904. So my Ka value is 1.2 times 10 to the negative 3 when we complete this. And here we have our Ka and our percent ionization of this weak acid.